Hi, everyone. We're going to get started as folks will be coming in from the coffee break. So I'm Mandë, Holford. I'm the moderator for this session, and I'm going to start off by setting the scene a little bit for what education in science diplomacy means. It's always sort of a dubious term, and if you ask 5 different people what science diplomacy is, you might get 5 different answers, depending on if you're speaking to a scientist or a diplomat or a decision maker or policy practitioner. And so when we think about education in foreign policy or international affairs, it's not such a dubious term, right? Everyone sort of knows that path. You're going to learn about decision making, you're going to learn about international issues, you're going to learn about how these things are brokered and what are the frameworks involved, and a little bit about the history of the field. And here's sort of some stats from the State Department of different schools. So for several years, various schools have had foreign policy and international affairs as a part of their education system and a part of their curriculum. And it's a very established field, and this is how the State Department, USAID, international agencies, universities that deal on both the national and international level have fed their international programs. And so as shown in this stat, a lot of them come from Georgetown University, but everywhere from Georgetown to Yale, there's a program for how you teach and educate the next generation of international affairs or foreign policy officers. But when we think about, again, what does education in science policy mean, nothing really pops up immediately, right? And so we know that it engaged in most part STEM practitioners, right? So science, technology, engineering, and math. We know that it has something to do with policy making and decision making. And we know that it also addresses global issues. But these 3 are all sort of moving targets, right? So if we think about STEM right now, it's the best, most exciting time to be a scientist. With CRISPR and all of these things going on, it's really a cool time. And so with STEM, there's no fixed technology, there's no fixed science, it's all changing, which we like, it's always advancing. In policy making, it's kind of this up, down, it can go very fast or very slow, in which decisions are being made driven by who's the leading party or who's the elected official and who's heading which national or international institution, and then global issues, right? So global issues are also not static. Where did Zika come from? No one was prepared for that, right? The Ebola outbreak that recently also happened. So global issues are also a moving target, and it's all very intense and always reactionary at some point. So how do you teach a moving target? How do you engage all 3 of these things in a way that's going to be a didactic curriculum to infuse the next generation of not only scientists and technologists, but also policymakers, entrepreneurs, decision makers? How is this possible? And so an attempt that we've made and that I've been involved with is this course that we do at Rockefeller University, which is funded by the Hurford initiative. And that course is designed mostly to try to teach science diplomacy to biomedical researchers. It's a course that I do in collaboration with Jesse Ossobel and Rod Nichols. And our design, when we started about 4 years ago, and we were one of the sort of inaugural programs trying to encapsulate how do you teach science diplomacy to a group of scientists, we decided to focus on biomedical research because that's sort of the expertise that I had. It's also the expertise of the institution. And the idea is, how do we infuse the next generation of scientists with the thought that their science can do more than just and cause advancements at the bench. They could actually contribute in meaningful, impactful ways to global issues currently now and in the future. And once they graduate or move on from Rockefeller, so our course also has grad students, postdocs, and some early career faculty that take the course. Once you're planning out your career in science, you don't have to leave the bench to be a science diplomat. Actually, we want that expertise. Science diplomacy says science first, right? So we need that expertise there as well. And so once they leave the bench, once they move on from Rockefeller and go into other career paths, how are they going to continue to infuse this engagement with international and with foreign affairs? And understand that, okay, if I'm thinking about a vaccine, and here I am in New York with all this high-tech equipment, but the vaccines actually could possibly be implemented in a developing country. So maybe I should design it in a little bit of a different manner, right? It's kind of like Rita Caldwell's cheesecloth. What's the maximal thing that I can do to get benefit from it? So the idea is to expose these students to the fact that your science could be global, it can have broad implications, and you can start now. You don't have to wait till you get your Nobel Prize. If this is something you want to engage in, go ahead and do it. And so I'll tell you a little bit about what I'm doing. So I'm a scientist, and I work on venomous marine snails, which I call killer snails. And I engaged in science diplomacy because my snails are found tropically all around the world in any tropical marine beach. And those had some issues that comes along with access. So we need export-import permits. We need to be able to get our samples in and out of the countries we're going to. We need to ship equipment to these samples as well. It involves setting up international collaborations because we use a lot of local experts while we're in the field to help us not only identify what the local habitats of these snails are, but also access the communities in a friendly way. So we're sort of not doing what sometimes is referred to as science colonialism, that we're just coming in, grabbing stuff and leaving and not contributing to the local community. That's not at all what we want. And in the long term, my research at looking at the evolution of these snails could potentially lead to drug discovery because they have a venom that is very potent and can have benefits to human health. And so that brings in issues of IPs. And so who benefits if a drug is developed? Should it just be the institution that put in the R&D, or should the natural country from which the organism was discovered get something from those benefits? So as a scientist working at the interface of research and science diplomacy, all of these issues are what we have to deal with, and encapsulating it under the umbrella of science diplomacy engages the fact that very much we need STEM practitioners, we need to deal with ministries of science, we need to deal with local governments, and we need to incentivize and work collaboratively. But so one major challenge that happens when I'm talking about science diplomacy to scientists is something that's kind of pictured here. Scientists get worried and they don't want to be eaten up, right? Like this fish in the video. So the snail would be the policy makers or the decision makers, and the fish is the scientist. Scientists are worried about politicizing their science. That's not a gain for any of us, and we don't want to be used as pawns. So when you're teaching science diplomacy to a group of scientists, like we do in our Rockefeller course, it has to be stressed very carefully that this is a neutral process. You're here because of the integrity of science. You're here to share your expertise. You're here to move forward whatever the project is. It's not necessarily to advocate for a particular position, pro or con, for your country. And you're not going to become a meal or for somebody's idea of what's going on. So this is Conus tulipa, and it will eat the fish and then inject the venom into it and have itself a really nice, delicious meal. These are the things I study, which I love them. And so the challenges to teaching science diplomacy involves keeping that neutrality. How do we keep science neutral so that when you enter into a foreign government or into a foreign country, you're not perceived as an agent coming to do something other than the research that you're there to do, from a scientist's point of view. And then what degree of training is necessary to practice science diplomacy, both from the science or STEM standpoint and also from the policy standpoint? How much policy do you need to know as a scientist in order to engage in this practice? And how much science do you need to know as a diplomat or decision maker to really effectively have impact? And then, of course, what models do we use in education? So there are the traditional Bloom models of connectivism and constructivism and performance support, and the more recent things about blended learning, right? So having a flipped classroom where the students actually go out, having rotations or internships where we place people in different offices, All of these are different models to experiment with. And as we talk about education and science diplomacy, it's very much on-the-job learning right now, because we're not quite sure which of these models are actually going to work and which of these models are scalable, so that we become like when you hear the word, I have a degree in international affairs. Everyone knows what that means. When you say I have a degree in science diplomacy, it's like, maybe. Can you tell me what that means? So we need to figure out how to get there. And so that's sort of what the panel is going to help us do today. Today we're going to talk about the opportunities and challenges to teaching science diplomacy. I started off giving you a little snapshot of, as a scientist viewpoint, when I teach science diplomacy, what I'm engaging in. We have on our panel Kathy Olesko from Georgetown University. She's a historian of science. She's going to tell you a little bit about what they're doing there. Melody Brown-Berkins from Dartmouth College. She's engaged in several things, policy administration as well as academic coursework. She's also a fellow AAAS fellow. And then Matthew Daniels from the Office of Security of Defense. Matthew's sort of our bootstrap science diplomat. He's in the field doing it for real, and soon might be teaching it, but his experience is also one in which we want to engage. So with that, I'm going to start with our first speaker, Kathy Olesko. So Kathy, if you'll come on up, and we'll start. So the way the session will work, each speaker will speak for about 10 minutes, and then we'll have maybe time for one quick question as we change slides. And then we're going to have a full discussion with the panel and then open it up for question and answers at the end. So, Kathy? Oh, all right.
I'm in the program in Science, Technology, and International Affairs at Georgetown University School of Foreign Service. It's one of the undergraduate majors for students in the school. It's the second most popular major for undergraduates. We don't train scientists there. We're asking that those people, the young people who are intending to go into international affairs, international relations, to foreign policy pursuits, know a bit of science. And this particular major serves that need. And I want to emphasize that in our class, this gateway class that I'm going to talk about, STIA 305, is a course on science and technology in the global arena. So we put the global arena first. We don't put the science and technology first in this particular class. So we have a particular perspective on science diplomacy. It's not the problems that scientists have when they work in different nations around the world. It is instead, what are the scientific issues that are paramount within international affairs today? Students who come into this class already have a very, very strong training in the social sciences. So they've already taken international relations, they've already taken comparative political systems, they've taken 3 non-Western history courses, and they've also taken 4 econ courses before coming into this class. So they've taken microeconomics, macroeconomics, international trade, and also international finance. In the course of the major, though, this STIA 305 begins the major, but they will also take 6 courses in a science, so essentially they have a minor in one of the sciences, electives in their particular concentration, and I'll show you what those concentrations can be, and they also have a capstone senior thesis, so everybody is required to write a senior thesis on some aspect of science and technology in international affairs. The modules to this course mirror the 4 concentrations within the STIA major. So we have environment and energy, business growth and development, science and technology and security, and global health. In the course of the course itself, each of these particular modules are capped by a simulation in which students get to act out particular problems within the area they have just studied. So for environment and energy, we do a Mercury negotiation. For business growth and development, a Mandë project. For security, we do a South Asian nuclear crisis. And for global health this year, we did an Ebola outbreak simulation. And these simulations are a lot of fun. They love doing it. So every year in the South Asian nuclear crisis simulation, for instance, the team that represents the Pakistani army essentially throws the whole room upside down and behaves as Christine Fair, who's in our security studies program, describes the Pakistani army in her book, Fighting to the End. I finally decided to make this real. They have to read some of Christine Fair's books, so they at least follow contemporary reality in the behavior of the Pakistani army. So I want to look at some of the concepts that we teach in this class. We see science, technology, and international affairs as an integrative system, one that's built upon first a robust scientific, technical, and medical community across countries and within countries. We teach them in how research and development take place within countries. If you're going to do the economic angle of science, technology, and international affairs, you have to talk about regulatory policies, competitive markets, and intellectual property protection. We acquaint them with national advisory positions in science and technology, international organizations, and then finally, how treaties, protocols, and conventions are shaped within the international arena. And we see this as a very, very broad, integrative system in the course itself. To be sure, you can't teach all of this in every single module. It would just be impossible to do so. But each of these layers of this infrastructure are hit upon in the entire course. So let me turn now to some of the key concepts that we take up in the course. The course starts off with climate change, and one of the premier features of the science in climate change is a long history of scientific uncertainty that finally the last IPCC in 2013, I think, ranked at about the 95% certitude level. But students need to realize that in scientific knowledge, there'll always be a degree of uncertainty, and we want them to recognize that so they can engage in rational decision-making and advice under difficult conditions, that is, in an area where someone could raise a question about whether or not they are using the science properly. So climate change for us is a paradigm case. It's a way of getting into many of the problems in the rest of the world in terms of the procedures that can be used. We also want them to be aware of risk, because risk in decision-making has to be mitigated, or at least has to be managed in some way in making a policy decision. And we want them to be aware, too, that what are the facts in science are the results of scientific consensus. There can be a lot of competing facts that are out there, but we have to look for the area where the experts have the greatest degree of consensus. We take them into the process of decision-making by teaching them how to use such tools as the precautionary principle, which appears in the IPCC report, but it's also used for dual-use research of concern. And that takes us into the governance of science and technology within the scientific community, such as in genetic engineering, in the Asilomar Conference, or in the way H5N1 was handled, or in the way CRISPR is now being handled towards in a way that's now called, through a method that's now called tacit diplomacy. And we want them to realize that there are culturally appropriate solutions to certain problems, that it is not a one-size-fits-all world, that what suits one nation may not fit another nation or region around the world. Reading is a very important part of the course, and that may sound trite, but the challenge here is to teach students how to read scientific articles, not necessarily the opinion section, the news section, or the feature section of Science or Nature, but rather to get into the actual scientific articles and to be able to understand in particular what models are being used to interpret data and what degree of certainty can be ascribed to the data in the articles. And the science readings would include peer-reviewed reports such as the IPCC 2013. As an undergraduate course, though, this one, STIA 305, is also interested in giving students a perspective on science and technology over the long term, and that means for the School of Foreign Service since 1945, and understanding the role that science and technology play within certain cultures. So we teach them the background to, for instance, the national security state by looking at Audra Wolf's book, Competing with the Soviets, which gets us into the massive transformation in science policy in the United States following the Second World War. Scientific uncertainty is handled in Merchants of Doubt, a book that I know many of you know by Naomi Oreskes and Eric Conway. There's also a thematic journal of Osiris that's dedicated to global power knowledge, in which the problems of science, technology, and international affairs are treated. And finally, we take a classic article from Langdon Winter's The Whale in the Reactor, his article on Do Artifacts Have a Politics, so that they understand that in different situations, technologies can have political dimensions as well. This is not an easy course to teach. One person used to teach it in the past, but now we use a team. So at any one time, there are 4 people from our program teaching this class, the 4 sections that I showed you earlier. And each person in here has a policy orientation, except for me. I'm the outlier. I'm a historian, and I was never actually trained in policy. So Mark Giordano, for instance, works on water management policies globally. Joanna Lewis, who's on the IPCC panel, works on environmental issues, energy transitions, and broad-scale energy problems. Rajesh, a new member of our team, is going to come in September to teach IT and development. Robert Gallucci has been around Washington, D.C. for a very, very long time. Bob was the principal negotiator for Pakistan, Iran, and North Korea on nuclear issues, and we're very happy to have him as an honorary member of our team. Emily Mendenhall, an anthropologist, teaches global health. And Sarah Johnson, also a new member of our team. She works on the Mars mission, she works on biosignatures, but within the program itself, she handles space policy and environmental courses. The course was originally created by Charles Weiss, who was the first science advisor to the World Bank. I hired Chuck in 1977 to replace me as director of the program. He has since retired. He was here earlier today, but had to go to New York City with his wife, Edie Weiss, in order to celebrate Mother's Day this weekend. And for those of you who are interested, Chuck has 2 terrific articles in Minerva on science and technology and international affairs. The first one on teaching this particular course, and then the second one, a much more mature expression, I think, of how science and technology affect international affairs, and I thank him for the course that he sent us on. I have here for you copies of the STIA 305 syllabus. They're located on a stage down here. You could pick them up on your way out so that you could see how the course is taught in much greater detail. And thank you. Did you want me to take questions now?
Yes, we'll take a few questions.
Yes.
So thank you for your talk. That was really good. I think that class would be very useful for scientists as well. So I was wondering if you were considering doing a Coursera course and offering this online.
I'd have to ask my director where we are at Georgetown with online courses. We do have scientists in the class. So the class is not just made up of STIA majors. We also have science majors in the class who put the course to very, very good use in landing a job here in Washington, D.C. So yes, we do teach scientists. There are times we teach it at the graduate level. We're not next year, but we might be in the future. I'm not sure.
Thank you, Kathy. Our next speaker is going to be Melody, and this one. Sorry. Melody is the Associate Director of Programs and Research at Dartmouth College. She's also the John Sloan Dickey Center for International Understanding, and as I mentioned before, a former AAAS fellow. And so the way the panel has sort of been structured, we started with Kathy, who is, timer's up. She was very efficient. We started with Kathy, who gives a very traditional course at the Georgetown University. Melody is giving something that's sort of in between, and then as I mentioned before, Matt will close us out with on-the-ground sort of field work, field specialist type experience. So I'll turn it over to Melody.
Try to stay just as efficient. So, well, thank you, everyone. This is such an honor and excitement to be here, as I mentioned, and it's in one of my slides. I put a lot of different hats up here on the, did not put, it'll be in the next slide, a very, very proud AAAS Science and Technology Congressional Fellow from 1999-2000. So I titled my talk on this, Education and Science Diplomacy, Encouraging and Training Next Generation Leaders in International Engagement, because that is the intention of what I'm trying to do. I got that from the AAAS Fellowship, and I would like to see it done even further up the pipeline, and let undergraduates, graduate students, postdocs know that this is a possibility, some who haven't heard about it, and just give them, it's a primer, but it's also a little, I will say it's got a point of view that this is a really exciting and emerging, it's a field that's been around, but it's emerging in new ways, and it'd be fun to be part of it. So I am the associate director of a large international understanding center at Dartmouth College that sends students around the world, gets faculty involved in policy-relevant, globally engaged research. I'm also an adjunct professor of environmental studies, which is where I teach the course. I also serve as chair of the U.S. National Committee for the International Union of Geological Sciences. You don't have to know what that is, but it does connect geologists around the world in a wonderful network. And I'm a member on the board of international scientific organizations. Both of those are under the national academies. This is another organization like AAAS, a different model, but connecting scientists around the world, trying to facilitate international collaboration. So I really believe in all of this work. I have to go here. So just as a first note, I started as an earth scientist, just to give you some background. Worked in the Bering Sea, worked in Southeast Alaska, in glaciers, then in mining in Mexico, specialized in soil biogeochemistry of extreme environments in the Antarctic dry valleys. This is a picture of Wright Valley. I worked with a long-term ecological research program in McMurdo. So I was very much drawn immediately towards interdisciplinarity, extreme challenging environments. I loved being a geologist. I was fascinated by the science, but as many of you in this room might also think, I was also fascinated by the connections to mainstream media, things like global warming. This was back in the 90s. Global warming, canary in a coal mine, what was the Antarctic environment, extreme environment telling us about the future of the Earth? An analog to Mars and the future of planning for space travel. That was also in the Antarctic dry valleys. I was also drawn to the idea that there were senators who would visit us and ask us about our funding and why did it matter? Should we be funding research in Antarctica? They got to go and see Antarctica, then they got to ask us if this was valuable, and we had to have an answer. So I was asking myself, why, what value? It all resonated with me, and I was wondering who was able to answer those questions, and they all the people who seemed to have that training seem to live here. So that drew me to Washington, the Congressional Science and Technology Fellowship. I worked with Senator Patrick Leahy, which was absolutely wonderful, of Vermont. I was his Energy, Environment, Natural Resources first fellow, then aide. I stayed on for 3 years as his policy aide. I loved the work. I loved public service. I loved problem solving. I loved strategizing. I loved connecting with Earth and ecosystems issues in a policy sphere. But I wanted to head back north at some point. I wanted to raise a family up in the North Country, which the senator understood. And I still loved what I did, and I wanted to take it with me. And that's been sort of my career since then, is trying to figure out ways to do that. Whoops. I will figure this out the other way. Okay. And I will say that, I come at this as a practitioner as well, which is I think what was mentioned. When I was up being a scientist, engaging work in Vermont, when I went back to higher ed, I went to the University of Vermont. I also worked in local. I worked planning commission. There were 6 of us. I worked on potholes. I worked on road funding for roads, state economic development. How does a small state keep its Medicaid and its roads fixed, its pensions regulated? How do you have government affairs? How does higher ed showcase its value to higher education in Washington, to the state legislature? How do we engage internationally? How do we do distance education? Science policy exchanges. I was put on a governing council of how do you get science into impact. There were a bunch of a consortium of Northeastern universities looking at that. So I started to gravitate towards that. I started working with the U.S. National Committee for International Union of Geological Sciences, working internationally. And I became put on the board on international scientific organizations. So it was in my blood to try to figure out how to do this. But again, there weren't that many of us. And then the Dartmouth opportunity came up, which is the world's troubles are your troubles, and there is nothing wrong with the world that better human beings cannot fix. That was said by John Sloan Dickey, longest serving president of Dartmouth College, and this center was established in that name. And I saw a wonderful opportunity to become the associate director and work not only by sending students around the world to engage, but infusing some science, technology, and innovation ideas in this, and also teaching. So go back one. Environmental studies is a great place to do this. It's a very interdisciplinary program. That's where I'm an adjunct professor. And here's more of what the actual curriculum looks like, because I know this is probably what people are often looking for. But let me note, and I'll go into it in more detail, that what it is called the practice of science policy and diplomacy. So I'm not teaching, I think there should be all of these courses. There's a history, there's a what's going on now in current affairs. I'm teaching this from the point of view of how do you practice science and policy and diplomacy? What are the skills you need beyond your scientific training to engage? And to be honest, a lot of them are not just science specific. So the course objective and background. I'll just go through it so you knew exactly what I'm hoping to teach. The course is designed to introduce students to the global landscape, emerging ideas, and the art and practice of science policy and diplomacy in the US and internationally. Coursework is highly interactive, emphasizing how scientists and non-scientists can most effectively engage in science policy and diplomacy activities in the US, in international organizations, and in their careers. Class time is emphasizing current issues in science policy and diplomacy, the development of policy briefs, that's huge, and other strategic communications and comprehensive policy analyses that include social, economic, and political concerns, as well as the science and technology perspective. I love to have guest lectures by faculty and distinguished practitioners at the intersection of science, policy, and diplomacy, who bring unique perspectives about the advancements of complex policy and diplomacy issues at the regional, national, international levels. And students have to complete a final project in addition to policy briefs throughout the course, in which they develop and present a policy brief with recommendations for next steps that are relevant to a US legislative and/or diplomatic activity. So I'm really trying to get them to understand what this all looks like. And by the end of the course, I do have learning outcomes. In education, you want to specify what those are. And I also had to do this because this course has to go through multiple curriculum committees who don't know what science diplomacy might be. So I wanted to tell them what I think the students need to learn, and all these curriculum committees have to believe it's valuable. So in some way, I'm also educating my fellow faculty about science diplomacy. Understand the broad scope of activities categorized as science policy and diplomacy, and learn about current professional and political trends. They should understand the broader social, political, and economic context in which science policy decisions and science diplomacy activities are developed. They should gain an introduction to the skills needed above and beyond scientific knowledge and technological expertise to engage in effective science policy and diplomacy activities through trusted science policy and diplomacy networks, like the AAAS network. They should distill complex scientific, social, economic, political, and cultural issues, arguments, and positions into clear policy briefings with recommendations for decision makers. And that is usually what, less than half a page if possible, half a page to a page at most, bullet points. Understand emerging trends in scientific communication and engagement by science policy and diplomacy professionals, including the use of social media. I've made that very clear that they should be looking at that and following trends and understand it, because it's becoming a really rich ecosystem for study. So this is what it looks like. we have 10-week courses at Dartmouth. They're very short, they're very fast. And I'm trying to do a lot, and I'll change it up. But the first half of the course is actually science policy, getting them, because there are a lot of the same skills in both. And we do a lot of overview, but we actually get into presenting science to policymakers. We do policy roundtables. I have them talk to each other quite often in the class, as often as I can, prep ahead of time, then actually put them in situations where they have to convince each other. I talk about science policy communications. I talk, and working with the media. I talk about ethics, and we talked a little bit about what are the boundaries of when you're an advocate versus when you're just informing policy or diplomacy. Talk about working with legislators, managing conflicts of interest in your own research, and when you're getting funding, what you're able to do in the policy and diplomacy sphere. We talk about networks. We have lots of presentations. Second half of the course, we move to science diplomacy, and I draw there's not a lot out there. I draw very heavily on the AAAS website, by the way. Really fascinating, rich papers, documents, science diplomacy, education is excellent on this front. So I draw very heavily on the readings. I talk about international science and technology organizations, because that's one kind of science diplomacy, is just international collaboration and facilitating that. We have roundtables. We do scenarios and simulations whenever possible. I talk then in science diplomacy a little about what are the big things happening, polar diplomacy. For that, I bring in, we actually have one of the lead Fulbright Arctic Initiative scholars. I'll say that in another slide in a minute, who my former PhD advisor, actually. We talk about national perspectives, different countries. We talk about gender and STEM, and we talk about international security. And so then we also wrap up with discussions and presentations. I'll just go quickly through this, is that we ended the course and I had the students want to do this in real life. They applied to be a part of the Model Arctic Council. The US is the chair of the Arctic Council right now, and there was an opportunity in the University of Alaska Fairbanks, with which we collaborated at Dartmouth, to go to the Model Arctic Council. The students joined these kinds of groups, and this was for the Protection of the Arctic Marine Environment Working Group. This was for the Sustainable Development Working Group. They met with policymakers, Senator Lisa Murkowski. This is the Coast Guard group that was running one of the simulations. They met with the lead, Admiral Papp, and David Bolton, are actually two of the leads for the US as we chair the Arctic Council. They actually gave a declaration, a full declaration that it will actually, David Bolton said he will take to the full Arctic Council and see if they will actually look at it for real policy. Next steps in my world are seeing what the next course will look like, connecting this to a lot of the other programs that are going on in science diplomacy and learning from them, developing a workshop. I think someone just mentioned, how can these go further? How can we create them on video and get them into a larger audiences, both for students and for faculty? And the take home is that science diplomacy education for me is taking local, national, and global contextualization of any scholarship, but science in this case, adding in the idea of multidisciplinary and collaborative problem solving that we do throughout the class, and then adding in policy and diplomacy skills, policy briefs, writing for media, understanding your ethics, those skills for effective engagement, and that to me brings our next generation of science diplomacy leaders. Thank you.
So if it's a quick, short question, we can take it while we're swapping to the next speaker.
Who did you talk to about getting this course into reality at Hurford? So like if I'm a doctoral student at NYU looking at pitching something like this, how did you go about doing that?
I put it in my contract when they hired me.
Sorry.
No, but that said, I think I had to find a willing chair, and a willing chair was environmental studies. It is a challenge to do, but I think there probably would have been more, and I think the more I do this, I could probably take it to some other places as well. I think citing that it's happening in Georgetown, it's happening at Dartmouth would be helpful, and then seeing if you can get enough people to be put together, maybe even sometimes these ideas can be as a pass-fail at the beginning to just see if people will join up. Yeah.
Thank you.
Thank you.
Thanks, Melly. And so now we're going to have our third panel speaker, Matt, who's at the Office of Secretary of Defense. He's also associated with the Aerospace Engineer National and NASA, the National Aeronautics and Space Administration. And so Matt's going to give us his version of what education and science diplomacy is. Matt, come on up.
Thank you. Good afternoon. My comments are actually going to be relatively brief and also free of PowerPoints. Brief mostly because I think I've been talking for about what feels to me like 2 weeks straight right now, so my voice is starting to go, so that might even be the limiting factor of my talk. First of all, I come with a very different perspective because right now I'm on a sort of extended loan to a group in the Office of the Secretary of Defense that does long-term strategy for the Secretary of Defense. But my longer background is actually at NASA, and at NASA I've done a combination of technical work, so designing spacecraft and science missions to near-Earth orbit and asteroids and the moon, but I've also through NASA done work with other countries. And that's where I'm going to sort of talk about this, what I'll call kind of bootstrapping science diplomacy. So I really, with that kind of background, I just want to mention 2 types of topics. The first is this idea of bootstrapping science diplomacy and what that looks like, and 2 perspectives on that, kind of how I've done that and how we've done that, and how we learned how to do that. And then, for my current job, the strategic value of science diplomacy. And from that together, I'll end with some comments about things that seem valuable to include in science diplomacy curricula. So how do we think about what we should learn to create practitioners in this? So when I was at NASA, I worked at a field center called NASA Ames. NASA actually has 10 centers around the country. I was at one of the ones in California. As part of our work, we built our own agreements with other countries. So we would develop joint small satellite projects with Poland, Lithuania, Colombia, Israel, South Korea, Singapore. And these are countries that were interested in small satellites because that's how they were starting their space programs. And it turned out that I was at this laboratory where we focused and had an expertise in small satellites. So we were NASA. We don't build international agreements for our day jobs normally. So when I say bootstrapping science diplomacy, I mean we were not trained in this. We were trying to figure out how to do this on the spot. So we were learning things like when we work with another country, it was often valuable to have involvement on the other side of a civil space agency, because that was a logical connection for us as NASA. But it was also valuable to have some involvement often of a military organization, because they brought stability of funding and a sort of bare-knuckle idea of project management, which is sort of necessary for engineering projects over multiple years. And then we also found that it was very valuable to involve researchers who were not in government at all, because they usually had the deepest knowledge base, and they were the ones who were going to bring a scientific angle to what we were working on. So when we developed these kind of projects, we found a few things. First of all, besides that kind of structure on the other side, we found that exchanging people was often one of the most important pathfinders we could do to building projects. So as a research laboratory, we could take interns. We also discovered that looking at each other's institutional capabilities matters a lot. So our partners internationally would look at us and ask if we had the technical chops to pull off what we were saying we were going to do. And we would look at them and ask the same thing. At the same time, we would also both be looking at each other and saying, does our partner organization have the capability, even just organizationally? Do they have the mandate to be able to do what they want to do, or what they say that they're going to do? So for example, if we say that we want to build a satellite together, do they have the authority on their side to actually go off and allocate funding for that? We found on our side that one of the things that we definitely could do, that we could say on the spot, we think we can do this, is taking interns, which sounds like a really small thing. And it turns out that this paid dividends, because having interns from another country embedded in our technical staff gave opportunities for American students to meet people, scientists and engineers from other countries, especially future leaders. It gave us a way to build a sort of natural bridge. So often we would have a student come, they would spend a few months with us, and then they would go back, and we would have someone on the other side who knew our organizational structure, who knew the types of projects that we were interested in, and who essentially also had our contact information. So these are the things that we had to figure out how to do on the spot. I realize it sounds sort of wandering. And the idea is there is a sort of value in that I think is unrealized when you're muddling through it. So let me talk about that from the other side. I've been asked if that's the kind of thing that we would do at a NASA laboratory, muddle through, figure out how to build joint satellite projects, end up in the process of that saying, well, let's start by taking interns, and then we'll kind of see how it goes from there. How do we think about that in a much broader context? When I, for my day job right now, think about space security and think about issues for Secretary of Defense, we have some big problems right now that we're thinking about in DoD regarding space security. And on sort of the long list of things that I think the leadership of, for us, the Department of Defense, but it could also be for other countries, their ministries of defense, can do in this area, cooperation and building international agreements is one of the major things on that list. Often when we talk about international agreements in a security area, we're talking about restrictive agreements. So we talk about arms control, or in the case of space, usually rules of the road. A neglected form of international cooperation that really has a lot of value is cooperative agreements. So instead of saying, let's all agree not to build a certain class of things in space, building agreements around what can we share data, can we exchange researchers, can I put an instrument on your satellite, would you like to put an instrument on my satellite, those kinds of agreements. Those can actually have national strategic value because when we think about countries that we struggle in our relationship with politically, a lot of potential for miscalculation or accidents can turn on not knowing each other's cultures, not understanding each other's operational procedures, not knowing each other's organizations. I mean, really, it turns out it's the basic stuff. Knowing organizationally who to call on the other side if you have a question. These are things that we don't always have answers to. And having done scientific collaborations gives you that kind of access and gives you a kind of wisdom about another country's technical culture. And it's very hard to get that through other channels. And it's hard to build that outside of scientific cooperation. So there's this interesting thing, that laboratories, this is where my voice is going to start going, laboratories can have what, from their perspective, is a sort of muddling, bootstrapped version of science diplomacy, where they can go through that. The other side of that coin is to be able to say that actually has a national strategic value, which is interesting. So what do we make of that from an education perspective? How on earth do we draw lessons from that about what we should teach in curricula, or how we should build education programs, especially for undergraduates? I have four thoughts. And these are, I'm going to offer these mostly because I think they're going to be different from what is normally discussed in this kind of context. So I offer them in that mentality. The first is actually, I think, the value of military history courses, or courses on military history, of all things. Robert Neer just wrote an excellent article on this, about the dearth of these kinds of courses in US programs. The US spends on the order of $600 billion a year on our defense. And our military has an enormous impact on our own society and on the lives of many other people around the world. Understanding how our military has evolved over time and how it has a relationship with our American society is incredibly important. It's also important because the Department of Defense in the United States employs a huge number of technical people. So it's very possible that A, people coming out of these kinds of programs could wind up working with or for the Department of Defense. But absolutely, they will probably be interacting with people from the Department of Defense. So, first thing that I would offer is the value of understanding the military. Second is, I think actually touched on by my colleagues extensively, the value of simulations, the value of trying this. I think when I was thinking about this ahead of time, I was going to talk about, or I wanted to talk about building projects or thinking about interactions and discussions between states on technical subjects with specific goals in mind. And it's with these specific goals in mind that it's hard to get that outside of a simulation. It's hard to see how that, if you're really trying to either build an agreement or do a project together, it's hard to get that outside of doing some sort of simulation. So value of simulations seems incredibly important. My final two, visiting labs, especially for people who are coming from social science, history backgrounds, the value of seeing major laboratories. This is, especially in the United States, a feature of our scientific enterprise as a country is big laboratories. And when we talk about doing joint projects, as opposed to, say, building international agreements, if we're going to do joint projects with other countries, often we draw on expertise in our national laboratories. So seeing those. And last and perhaps most abstractly, the value of mentors. Mentors or exposure beyond a lecture setting to practitioners. The ability to just essentially sit and have coffee with someone more than once who's actually done this kind of work. I think there's a certain value in that that's not unlike a kind of apprenticeship. So that is a different view on this.
Yeah, that's perfect. All right.
Thank you.
Thank you very much. So you can have a seat. 'Cause
Okay.
now I'll bring everyone up and we can have a quick 10-minute discussion amongst the panel. So Kathy and Melody, if you want to join us on stage. And then we'll have 10 minutes for Q&A from the audience. I was told we have to end in punto at 4:20 very much. And so we're going to try to stick to that schedule. Okay, and so, thank you all for that really nice intro as to what's going on from the different perspective, a very structured program, a sort of blended mixed program, and then ideas about how you can do these programs from someone who's in the field. And so one thing I wanted to address sort of initially is how do you keep your science neutral? And for you, you can talk about the history of how science has been kept neutral and sort of get your standpoint on when you're engaging, especially as you said, when you bring NASA out to all of these countries. How do you make sure NASA isn't viewed as a military organization and from the US, right? And when you're engaging with the Arctic in your Model Arctic panel, how do you make sure the science there isn't being, pushed and shoved? Is there climate change? Is there not climate change? And in what can we learn from the history of science about how neutrality in science comes into international affairs? So if you can all just quickly give us some few points about that, that would be great.
Well, I will say one of the things I do emphasize in the course is to be aware of this. I tell the students that there is a reason for the scientific method, there's a reason for peer review, and they have to understand that. We go through it. And we also talk about the pushes and pulls of policy and diplomacy and the agendas that can be out there. What I try to talk about is ethics and integrity and understanding what part of the line you are in terms of informing issues or advocating for issues, and to be aware of what other folks are doing in power structures. So in my course, it's really an awareness that this is an issue and that they have to constantly be self-checking, and if they're a scientist, they have to be self-checking on this. If they're a policymaker, they have to be understanding what the science is that they're bringing and how they portray it. So I try to bring it in that perspective of really being aware that there are these tensions, and for them to be hyper aware of it, and if they're informing or if they're advocating, they have to know the difference and make bright lines.
Matt?
I can add a comment just very briefly on an experience with NASA. So it's very important to me that NASA not be seen as a military or intelligence organization, because it's not. And that's an interesting line to walk sometimes, because when you go to another country and you're part of a NASA delegation, everyone is very conscious of the fact that you are from the US government, but you're not from the State Department, and there's usually sort of a search for the box then to put you in. So we sometimes have to sort of explain to other countries that the US actually has 3 space programs. We have a civil space program, we have a military space program, essentially in the Air Force, and we have an intelligence space program called the NRO, the National Reconnaissance Office. And we're actually quite distinct from those. There is no real way to do that besides being very conscious ourselves of how we communicate and what we say, and of focusing our discussions on very transparent projects. I think we also, as an agency, NASA does, there are technical things that you can do as well. Sharing data in certain ways, even thinking about how you use encryption, where you can actually be quite open with things that you're doing as a sort of proof of transparency.
Kathy?
One of the major debates in the history of Cold War science concerns the militarization of science. This theme began about end of the 80s with an article written by Paul Foreman on quantum electrodynamics and use of quantum electrodynamics by the military. That particular thesis has been hotly debated in the history of science, with people coming down on either side, that is, that you can see science as not being militarized during the Cold War, and that in fact the money that the military poured into science during the Cold War resulted in the great expansion of many areas of investigation in the scientific community. Is that still with us today? You know, I think we have to sit back and reflect upon things like dual-use areas of research of concern. Because dual use means that a particular scientific discovery can be used for military purposes, or it can be used for civilian purposes. And most of our regulations are tied to the effort to prevent military uses of dual-use research of concern. So certainly nuclear reactors are dual-use research of concern. CRISPR is dual-use research of concern, and you could name many other areas of science that might also be dual-use areas of concern. So it is an ethical problem, as my colleagues have stated here, to be aware of the ways in which science can be utilized, but I think from a historical perspective, we also need to be aware of interpretations that have been made of science and technology since 1945 that raise questions about whether or not science is in fact neutral under all circumstances.
That's a very good point. And so the other thing I want to address is what degree of training do you think is necessary to engage in science diplomacy? Kathy, in your talk, you mentioned Bob Gallucci, who is he was trained in foreign policy, not in
Correct.
science or STEM, but he was very pivotal and instrumental in his contributions. And so from your standpoint, how much STEM is it necessary for a foreign policy officer to learn? And can you do the bootstrapping, even though he has a PhD and he's not bootstrapping that much, but can you do bootstrapping?
I think there's two kinds of bootstrapping.
Right.
There's the bootstrapping in diplomacy for the scientists, and then there's the bootstrapping in the science for the people who practice diplomacy and international affairs. I don't think there's any one size fits all in terms of training to go into science and technology and international affairs, I'll call it, since that's what we actually teach. Robert Gallucci was trained in the nuclear physics he needed to do the negotiations in Pakistan, North Korea, and Iran. So he knows a hell of a lot. And I don't think I would want to cross him on any occasion on his knowledge of nuclear physics and his ability to detect the misuse of reactor enrichment, for instance. So I don't think there's any one area of concern. Obviously, you have to have some kind of technical knowledge in order to engage in what's being called science diplomacy here, or science, technology, and international affairs, as we call it at Georgetown. We encourage our students to read as much as they possibly can in the sciences, to have, as I said before, the equivalent of a minor in the sciences, but most of their training also occurs on the job. They continue to learn in the careers that they have the more refined aspects of the sciences that they're dealing with. So I would say it depends.
And Melody, do you think there are metrics for doing science diplomacy effectively at a high level, since you've sort of straddled sort of the both worlds?
It depends. It depends where you're sitting. It depends if you're in a negotiation. someone with a very strong foreign service background and negotiating skills who has a little bit of science or knows to bring in the scientists at the right time can do science diplomacy very, very well, or maybe have learned it all of the science and technology during their career as well. A scientist may be best in a situation where it's really about international science collaborations and it's scientist to scientist discussions. And it's the secondary piece is a negotiation on the policies or the MOUs or international agreements. So it is a spectrum. I actually advise students, here's the global ecosystem of what science diplomacy, science technology, international affairs is starting to look like, how they're all becoming blended. The different entry points, that's what most students want to know. And I do say you're not going to be seen as a science expert if you go in straight out of undergrad. You could be part of the bridge, though. You still have a role. You just have to acknowledge that you may respect science because you were a chemistry undergrad, but now you want to get a policy and public affairs degree. But at least you know both worlds, and that's going to be your career. You may get it after a PhD and you do a AAAS fellowship, and you have a whole different sense of what you're bringing in your scientific and technological knowledge. Or you may be a senior professor emeritus, and then you have the ability, potentially the time, to go and learn some of these skills and travel and bring your scientific acumen. So it's a spectrum. What I'm telling students is that there are opportunities the whole way through. Again, acknowledge what you know. And also I do tell the students, you're creating this field. This is now, it's becoming blended faster than we know. People are tweeting about it, and people are connecting in new ways. Policymakers, community members are now becoming science diplomats. So follow it, figure out what these boundaries are, because we're trying to figure out what they are. We're trying to figure out some of those bright lines, but the next generation is probably going to be defining them and creating those jobs. And so I told them to go out there and make those happen as well.
Right. And so, Matt, maybe one way of teaching these metrics or figuring out what the guidelines are or the level of expertise necessary are through simulations and gameplay. And each of you sort of mentioned that in your talk, and I'm also a very big believer of using games and learning games in order to engage people and teach what's going on. They're didactic. People come with an open mind, they're creative, they're ready to learn. And so from your experience in engaging with either war games at the DoD or in the simulations that you do with NASA, are learning games or simulations an effective tool for how we can perhaps teach science diplomacy and then help to use it as a metric for how people are learning both the STEM and as well as the international affairs piece?
Sure. So I could say sort of a break from the NASA stuff. On the DoD side, yes, of course, we do many war games. There's in fact a resurgence of interest in war games right now. And as a sometimes funder of war games, we take a sort of two-part perspective. One is we fund war games because sometimes it's a way of doing experiments for us. That's how the DoD has done this for a long time. It's a way to learn about particular issues. But the other way that we get a lot of utility out of war games is an opportunity for participants to learn about issues and to work through issues. So interestingly, I mean, these are people who can be quite far along in their careers, can be quite senior, including senior military officers. This is an opportunity to see possible futures and potential contingencies. And there's a huge learning opportunity in that at all points in your career. It's sort of interesting. I was going to add one other note. As part of our earlier discussion, this idea that the field of science diplomacy is still being shaped and still being created. I think one of the interesting features of that too is the nature of global science is also changing a lot right now. I mentioned big labs in my talk, and I think it is important to visit big labs. But I mean, one of the notable characteristics of the last few years is that globally science is moving out of the big lab system. I think it's an interesting artifact that that's a deep talent pool for us in the US to draw on, to the extent that we bring people with very deep technical backgrounds into foreign policy discussions. We have this depth in our national labs, but the rest of the world, a lot of engineering, a lot of technology development, and a lot of scientific advancement is happening now outside of the sort of big nation-state, big lab system. And I think we're very much still trying to figure out how to interact with that different ecosystem now.
Want to add anything about the Model Arctic gaming simulation that you guys do?
Well, I will say that the Model Arctic Council was actually not specifically, it was steeped in issues of science and technology, but really run by policy folks, which is often the case. And the idea that there could be more science-based, science technology-based scenarios. I love seeing your list. I took a picture of that very quickly. And we'll talk more, and I know there's been some Twitter on that as well. So finding a cadre of simulations based in science technology would be great. The Model Arctic Council, actually, I am in conversations with them. I was just emailing that maybe we could do one that is specifically focused on some of the science and technology issues and the some specific ones rather than these larger policy briefs that we were working with. But it's still, all of those issues were part of it. The students had to have an ability to read the scientific papers, to read the scientific jargon in the Sustainable Development Working Group on global on health in the Arctic, and then one was on the protection of the Arctic marine environment. There were some significant discussions in there that were very technical, and they had to have that ability. So again, a lot of the students have to be able to go in these simulations and find someone who knows something. And again, that's what we're trying to teach students how to do. Yes, it would be great if you're an expert, but you also have this we have this wonderful opportunity to teach them how to learn and think about science diplomacy as a collaborative, as a multidisciplinary problem-solving event where they have to go and find the experts. So it's maybe you're not the science expert and the diplomacy expert. Maybe science diplomacy is when you've got 5 or 6 people in the room and together, you've got a pretty good team.
Right, exactly. And a lot of the initial games in the science diplomacy realm have focused, like Peacemaker, have focused on the policy aspect. And so how we bring in the STEM aspect in an engaging way is really an exciting area, and I think an emerging space for how to move forward in science diplomacy. If we can take both the policy simulations that are out there, like Model UN, and infuse a little more STEM into them, then we really can build this sort of dynamic sort of environment for teaching and also learning about science diplomacy. At this point, I'm going to open it up for the audience. And first, I'd like to introduce our rapporteur, Mandë Solar, who's here at AAAS. And she's going to come up and talk a little bit about their programs very quickly. Yes, yeah. And then we'll open it up for questions to the audience before we end. So, Mandë?
Thank you, Mandë, for giving me 1 minute of 2 minutes of your session. I was sad that I couldn't be a panelist, but of course we have 3 great ones. And I couldn't let the opportunity pass to tell you a little bit of what we do here at the Center for Science Diplomacy and how we approach training and capacity building. So we run this fantastic course every year in Trieste, in Italy, and it's in collaboration with the World Academy of Sciences, or TWAS. And we bring every year, since we've done this for 2 years, this summer will be the 3rd, and we bring around 30 or 40 young scientists from developing countries together with policymakers and decision makers for a very immersive program in Italy. And it's really remarkable that we had last year, for example, participants from Cuba, from North Korea, from Iran, and the United States in the same room. So that was quite remarkable. And these training programs allow us to bring these these participants together that couldn't perhaps interact in other settings, right? So we're very proud that we're able to accomplish that. And I wanted to touch very briefly on Melody's point of what the skills that are needed for science diplomacy training that are not scientific. And that's a very important point. So last year I joined ASU faculty to develop a pilot program on science diplomacy and leadership, touching again on the non-scientific aspects of the training. And we teach communication, cross-cultural competence, ethics, trust building, and it's a multilateral, multinational, multidisciplinary program for the Americas that brings together grad students from all disciplines, from all the countries in the Americas. And we do all the simulations and role-playing through improvisational theater. So we use the performing arts, and we have a fantastic professor of arts, film, and theater at ASU that now teaches those competencies and helps the students get into the character of a negotiator, and really the creativity and the imagination that unleashes is fantastic. So I just wanted to give these two examples of other possibilities and to expand our roster and catalog of science diplomacy training. Thank you.
All right. So now your turn. We have still a few minutes. So if there are any questions, there are 2 mics. I think it's being recorded, so they want you to go to the mic. But if you project, like I do from Brooklyn, you can just scream it out. I'm sure that they'll hear. So if we have any questions for the panel? Yeah.
I'm just going to yell. So as far as from the education standpoint, where do you see, this is a 2-part question, where do you see your students currently finding positions, utilizing the skills that you're teaching them, and where do you foresee in the future more positions opening up, and what areas do you think that those will be in?
All 3, or?
Either, whoever wants.
So I've only been teaching this a year now. I've already taught it 1 course, and I do not know where they're off to yet. We have a lot of discussions. Someone looking at global health policy, my guess is. Another one probably looking at running the UN. I think that's going to be her goal, and she's going to do it. So I think, I don't know where they're going to head yet. I do have a lot of students who come to my office sort of finishing up a degree and wondering what's next. I do send them often to AAAS, has quite a few resources on various career paths. And what I first try to do is really figure out if they want to stay in research, if that's their passion, or if they really couldn't stay, if they need to get out and work elsewhere for a while. And usually, so when they're asking those questions to me, I'm pushing it back on them of what do you really want to do. And I do say it, I've heard this in the career path discussion, until there's a career path, there isn't. You're starting to choose whether you go into science and technology often, or whether you're going into public policy and management. I have them try them both on and keep their options open. And then make it up. They have to figure out, and I give them a few fellowship opportunities. I look at programs, Stanford program that really does try to mix the 2 in a PhD. The Yale forestry program has a good science base, really active in the policy sphere. So I do try to give them some examples, but there is no one way to advise them just yet. And I would love to see a science diplomacy or a science technology international affairs track open where people had a more a path and a career like that and more expectation, but right now you have to make it up yourself.
So the program at Georgetown has been in existence since 1983, and I no longer have access to the complete list of positions that our students have acquired since 1983. But I could say in answering that question about where they get positions, you have to look at it in 2 ways. Georgetown is situated in Washington, D.C. It is the rare School of Foreign Service student who does not have multiple internships during their undergraduate years. So they get their feet wet first by becoming interns at one of the federal agencies, the National Aeronautics and Space Administration, the National Geospatial Intelligence Agency, the National Security Agency, to the degree that they could get in. There are a number of places where they have internships. Those internships, of course, are usually stepping stones to getting a position later on. And just off the top of my head, 2 students who wrote senior theses under me on nuclear issues have landed intelligence jobs at the Department of Defense. They can't tell me what they are, so I can't say with great specificity what they are. But plum jobs for the graduates of our program are located at the Central Intelligence Agency, the Department of Defense, the National Security Agency. Students also go into the Beltway Bandits in this area, which are consulting firms for the government. Many go into the aerospace industries because Lockheed Martin and Boeing both have locations here. Some go on to the National Geospatial Intelligence Agency. And we also had, at one point, one of the 6 general managers of Microsoft whose responsibility was India and the Indian subcontinent, was a STEA major. She has since left and established her own firm in the Seattle area. So there's widespread number of positions that these students go into, and the entree card for them is the major, science, technology, and international affairs, because during the job interview, this is what they talk about in addition to their senior thesis. They talk about how they pull science and technology together with international relations and international affairs, and 9 times out of 10, that just bowls the interviewer over.
We have time for one last quick question.
Igor Linkov, I'm with Department of Army, and I was Embassy Science Fellow in Berlin. Back to the previous question, it would be ideal to place more scientists in the U.S. Embassy because now we have none. And we published a couple of papers with those ideas, including like our discussion with the Department of State. The problem, though, is that there are no political will to do that. There are no political will to change kind of portfolio of what we have in the embassies. I think it's really damaging for at least science, and I'm with research arm of Army Corps of Engineers. So I clearly see that without scientists in embassies, we are missing a lot on building this science collaboration. And especially with countries like Germany, the future is in science and technology collaboration. And that's, I think, where all these new students should go eventually.
And the question is, we're sensitive on time.
The question is how we do that, I guess, sorry. The question is how we do that, and I guess one side is like develop education to prepare right people, but the other question is how we change
The culture.
kind of socio-political environment around this.
I mean, you know, it's
Thank you.
the integration of science and technology in the State Department has been slow and uneven. And there was a time when we did have a cadre of science attaches at various embassies around the world. I knew that the one who was a science attaché in Rome many, many moons ago was a historian of science, who actually was a physicist too. But what we're going to have to do is to take the next candidate, whoever becomes president of the United States, and make it clear to them that science and technology are top priorities in the State Department. In the State Department, too, we just lost one of our major scientific ambassadors, James Timby, who has retired. And I haven't heard yet who is going to replace him, but behind the Secretary of Energy at the Iran P5+1 talks was James Timby, who knew more about what was going on than the Secretary of Energy himself. So there are many layers to this kind of expertise that is needed within the State Department, and it needs to be ramped up, clearly, at many levels.
I'll just add, the Office of the Science Advisor to the State is doing a lot. And Francis Colon and Von Tarikian have several programs that they're trying to engage and ramp up and get science and technology and STEM practitioners involved with the work at the State Department, not just in their office, but throughout the whole entity. And so I think that we're on the right trajectory, and we're in good hands for engaging more with STEM. And also the AAAS Fellowship is a great feeder program for doing these kinds of things. And I know that perhaps there are plans to try to take that globally at different national academies in other countries. And so I think we're ending on a high note here in that it might have been bleak in the past, and diplomacy I like to describe as a 10-speed bicycle where not a lot of gears are getting used, but I think now we're starting to use more of those gears, and STEM is definitely one of those gears that are being engaged not only at the State Department, but also at different levels. So I have to thank you for your time, because the closing session is going to be in this room, I believe, and we have to wrap up. So thank you guys very much for coming, and thanks to the panel for being here.